Now, exactly, in this one we're solving, right? They asked us to solve, and they asked us to solve between 0 and 2 pi. Now, so if we're solving between 0 and 2 pi, we can't solve for this cosine of 2x and cosine of x like we did in the previous, like where we're just dividing by 2 at the end, because we need to isolate. They're not like terms. We need to get them to be the same. So I'm going to use the double angle formula for cosine. But if you guys remember on your formula sheet, there's 3 of them. And I told you basically, usually for evaluating, cosine of squared of u minus sine of u is usually the easiest. However, when we're solving or verifying identities, you might want to be looking into your other formulas. They might be easier. So in this case, if I want to solve, I want everything in terms of the same trigonometric function. Do you guys agree? I don't want sines and cosines. I want all cosines or all sines. So if I use if I rewrite cosine of 2x as 2 cosine squared of x minus 1 plus cosine of x equals 0, I can now rewrite this as a trinomial. And if I kind of think about this, Ulta, could you take your desk and actually turn it 90 degrees the other way? I could rewrite this with just variables. Forget about the cosine. Let's just rewrite it as x's. Now, if I just rewrite this as x's, does this look like something I have solved in previous time in my mathematics classes? Yes, right? You can solve this. We just need to factor. Right? So you're looking at what 2 forms are going to multiply to give me 2x squared. Well, I could say 2x and x. And then what 2 numbers multiply to give me negative 1? Well, it's positive 1 and negative 1. There's no other options. We just got to figure out which one goes which. Well, since they need to add to give me a positive, that means I want the larger product to be positive. So I'll make this positive because 2x times 1 is positive 2, and then minus 1. So that helped me factor this. Now all I'm going to do is replace my x with cosine. So you guys see how I kind of use that factoring to my advantage to factor this? Because I know this is confusing. So if you think about it like this, Keith, it can help you out. OK? Just put that away. Not out at all. No, just like away. Like, yeah. Okay. So now I can apply my zero product property. So I could say cosine of x equals 1/2. Cosine of x equals negative 1. Go to my unit circle. When is cosine of x equal to 1/2? Well, I know it's at 1/2 at pi over 3. Right? And when else is it? Yes?
How come cosine 2 of x turned into 2 cosine squared of x? Oh, wait, no. Wait.
You mean from here to here?
No, the first step. First and second.
Oh, from here to here?
Yeah.
I use my double angle formula, which is provided to you. It's the second one for cosine. Cosine of 2u.
Oh, I see.
Okay. So I didn't use the first one. I used the second one because I knew that was going to help me with factoring. So therefore, I have x equals pi over 3. And then when else is it? Well, it's also going to be positive down here, which is going to be at, let's see, that'd be 12 pi over 6. So that's going to be, no, I'm sorry. That'd be 5 pi over 3. And then when is cosine equal to negative 1? Well, that's going to be over here, negative 1 comma 0, which is at x equals pi. I could write those as a solution set. And there you go. So I have 3 solutions between 0 and 2 pi that is equal to.